Hey, my name is Felipe and welcome to my channel. In this video we are going to work with object detection using Yolov8 and we're also going to do object tracking using deep sort. So this is exactly what you will be able to do with today's tutorial. You can see that this is a video of people who are just walking from one place to another, and each one of the people in this video, each one of the persons in this video has a bounding box of a given color. And the way it works is that as long as the object tracking algorithm, as long as deep sort is able to track each one of the persons in this video through all the different frames, then the bounding box will remain of the same color. If I show you an example, if you can see this person over here has a brown bounding box, and let's track all these persons through all the different frames, you can see that the bounding box remains being brown through all the different frames in this video. And I can show you another example, for example with this person with a purple bounding box, you can see that this bounding box remains being purple through all the different frames, and the same happens with this blue bounding box over here, which means that the person is being tracked through all the different frames in this video. So this is exactly the project in which we will be working today on today's tutorial, and now let's get started. So let's get started with this tutorial, let's get started with this object tracking tutorial, and let me show you the repository we are going to use in this project. This is deep sort official repository, and we are going to use a fork I made from this repository, which is this one. This is my account. This is a fork from the official deep sort repository, and the reason I made this fork is because I needed to make a change, a very small change, a very small edit in one of the functions. So I made this function TensorFlow2 compatible, right? I am going to use TensorFlow2 in this project, and I need to make this very small change. But other than this is exactly the same repository of deep sort. So this is the algorithm we are going to use in order to do object tracking. And now let me show you the object detector we are going to use in this project, because if we are going to track objects, if we are going to do object tracking, we definitely need data and we definitely need annotations, we definitely need detections on which to do some object tracking, right? So this is exactly the algorithm, the object detector we are going to use in order to produce the detections we are going to input into deep sort, right? So we are going to use deep sort as an object tracking algorithm, and we're going to use Yolov8 as an object detector, right? So this is Yolov8 official repository, and we are not really going to use the repository itself, but we are going to call Yolov8 through a Python package. Yolov8 is available through a Python package, so this is exactly how we are going to use it. But this is only to show you how the Yolov8 official repository looks like, and I'm going to post a link to this repository in the description of this video. So now let's continue, and now let me show you the data we are going to use in this project. This is a video we are going to use in order to test how the object detection works and how the object tracking works, and you are probably familiar with this video. This is a video which is very commonly used in this type of tutorials on object tracking, right? So you are probably familiar with this video already, and you can see that this is a video of many people who are just walking around one place to another and so on. So we are going to use this video in order to test everything we're going to do on today's tutorial. So this is the video, this is the data we are going to use today. Now let's go to PyCharm, because I need to show you a file I have created. This is something like an auxiliary file I have created, which is going to make things much simpler on today's tutorial. It's going to help us a lot on everything we're going to do today, because this file is called tracker.py, and it contains a class which is called tracker. And this tracker is basically a wrapper around deep sort, right? We are going to use deep sort, but we are going to use it through a wrapper I created in order to make things much simpler, and in order to make all the process much more straightforward and much better. You can see that this wrapper has a few functions, and the idea of these functions is to just grab all the complexity and all the different details of how to use deep sort, so we don't really have to mind about all this complexity, and we can just use deep sort from a very high level using this wrapper, right? And a very small detail regarding this wrapper is that you can see I have hard-coded this path, which is the path to a model which deep sort needs in order to compute all the process and so on, right? In order to compute all the object tracking. This is a file, this is a path I have hard coded into this wrapper. So please remember to download this file, which I'm going to tell you exactly where it is in the description of this video. And please remember to save this file in exactly this location, right? If I show you my root directory, which is this one, you can see that I have created a directory which is called model data, and inside model data I have these 3 files, right? Please remember to follow the same structure, because otherwise this is not going to work, because this is hard coded, right? So please remember to do that, or please remember to edit this line so you can specify the location, the path to the model, right? Because you definitely need this model in order to run this algorithm. So that's pretty much all you need to know about the repository we're going to use, about the algorithm we are going to use, about the object detector we are going to use, the data, the video we are going to use in order to test the performance of today's tutorial, and this wrapper I have created, right? I have already shown you all these details, and now we can just start with our tutorial. We can start with our coding, right? So the first thing we're going to do is to clone this repository, deep source repository, but we're going to clone my fork, the repository I have forked and the changes I have made. Otherwise it's not going to work. Otherwise it's not going to be compatible with all the dependencies I have specified for this project. Let me show you super quickly the requirements file, and you can see that I have also specified the Python version I'm using, which is Python 3.7, and this requirement, which is TensorFlow 2.11. We need to make these small changes I show you over here in order to make this compatible with this TensorFlow version. So now we're going to clone the deep source repository I have forked. So we're going to clone the one that's in my account, and I'm going to copy the URL, git clone, and that's pretty much all. So I have cloned this repository, and this is, if I refresh, this is where the repository has been cloned. Because you can notice that if I go back to tracker.py, at the top of this file, you can see that there are a few imports which is importing files from deep source. Now, this is not going to work unless you clone deep source repository, so please remember to do it as a first step. So that's pretty much all. Assuming that you have already installed all the requirements, that you have already cloned deep source, that everything is just completely ready and you can just start working on this project, this is how we're going to do. We're going to take it one step at a time. It's always a good idea to take projects one step at a time. So let's start by importing OS and by importing OpenCV. Now let's define the location, the path to the video we are going to use, and in order to move one step at a time, the only thing I'm going to do for now is just reading this video, loading this video, and I'm going to display one frame at a time, right? I'm going to display using imshow one frame at a time, so we make sure we can read the video and we can visualize the frames in this video. That's what I'm going to do in order to get started on this project. So the video path is in ospath join data, and the video is called people.mp4, which is a very appropriate name for this video because it contains people. Right? It contains people walking, so it should be something like people walking.mp4, but people mp4 it's just fine. So now I'm going to call cv2.video capture, and I'm going to specify this video location, which is here, and this will be called cap, right? Let's take it one step at a time. Now what I'm going to do is I'm going to read a frame from this video, so cap.read, this will be read frame, and now while read, I'm just going to visualize frames from this video. So cv2 imshow, this window will be called frame cv2 wait key 0. Sorry, I'm going to specify Something like 25 milliseconds will be just fine. And obviously I have to read a new frame, so read frame equal to cap.read, and I'm going to release the memory before I forget, and I'm going to destroy all windows by calling this command. Okay, so that's pretty much all. So let's see if we can execute this piece of code successfully. Let's see what happens, and you can see that we are just looking at the exact same video I showed you a few seconds ago. We may need to adjust the these 25 milliseconds because I have the impression it's running a little faster than in the original video, but it doesn't matter. This is only to show you that we can successfully execute this video, and we can read this video, and we can just display one frame at every time, at every execution. And now let's continue. So we can read frames from this video. We are reading frames, and what we need to do now is to use Yolov8 in order to produce our detections, right? The detections we are going to use in order to input these detections into the object tracking algorithm. And in order to do that, I'm going to import from Ultralytics, import YOLO, and I'm going to do something like that. I'm going to define it somewhere around here, maybe somewhere around here, and I'm going to say model will be YOLO, and I'm going to specify the YOLO model I'm going to load, and I'm going to work with a Yolov8 pre-trained model, right? You can just use a pre-trained model from Yolov8 in case you don't have a model already, so that's what I'm going to do now. So the model is called Yolov8 nano.pt, if I'm not mistaken, and this is exactly the model we are going to use. So let's take it one step at a time, and let's see if we can just execute this code. Let's see if we can just create the model. Everything seems to be working fine because we didn't have any error. So now let's continue. Now let's produce our detections, and in order to do that, I am going to call model dot. I'm just going to call model, and I'm just going to open this parentheses because this is something like a function we are using, and I'm going to input the frame I have just read from the video, right? I'm just going to input this frame, and I'm going to call the output detections. In order to go one step at a time, again, I'm just going to print detections, and let's see what happens. Okay, you can see that I am getting something. I'm getting a lot of information, so everything seems to be working just fine. So we are moving one step at a time, but you can see that we are making a lot of progress. So now what we need to do is to unwrap these detections, right? Because we had something which looks like this. This is like an entire class. This is something that it contains absolutely all the information we need in order to work on this tutorial, in order to get the tracking and so on. But this may not be in the exact format we need it to be. So we need to unwrap all the information from here. I think it's better to call it results instead of detections, because I'm going to use detections later on, so maybe I can just use results. Okay, so results is a list containing all the detections. I am going to do something like this. I'm going to iterate for result in results, and as I am making the inference of a single frame, of an individual frame, this will always be a list of length 1. So doing this, we are iterating in a list of length 1. Long story short, we are doing this iteration, but actually we are only doing one iteration, right? There's only one object inside results, so we are just doing this for once. We could do it in a different way. We could do it like results equal results 0. We could do it like this too, but I think it's a little cleaner if we just do this iteration. But remember, we are doing this process only once. We are doing this iteration only once because there's only one object inside results. And now let's call another object, another list, which is called detections. This is where we are going to save all of our detections. And now let's do something like this. For r in results.boxes, I think this was something like boxes.data.toList, something like this, because this is like a very custom object type in Yolov8, and we need to make it to look something like a list. We need to be able to iterate in this object, and I think this is the way to do it. If this is not the way to do it, we are going to get an error, and I can just fix it. And once we are iterating in this object, we are going to do something like this, and we're going to print it to see how it looks like, and then we are going to unwrap all the information from within this object. Let's see. No, I've made a mistake. All right, because I'm iterating here, and actually it's here. Now everything should be okay. Everything is okay. And this is the results we are getting, right? This is R. This is the print we are doing over here, and you can see that this is exactly how it looks like. And this is all the information we need from more detections, right? This is all the people we are detecting in this video. And the way we are going to unwrap this information is like this. We're going to say this is x1, y1, x2, y2, and then confidence value, I'm just going to call it score, and class ID. This will be R, right? Remember that we are using a pre-trained model from Yolov8, and this model was trained on the Coco dataset, so we are detecting all the Coco classes. So we are going to have a class ID, which is exactly the class we have detected in this dataset. If I show you my local directory, my root directory, this is a file containing all the classes we are able to detect with this model, and this also tells us the index for each one of these classes. In the case of person, which is the object we are going to detect more often in this video, this is the first element in the list, which means it's the class ID 0, right? It's the index 0, and if I go back, you can see that this number is always 0 for absolutely all detections. Now we have detected something different than 0. This is 14. Maybe it's another object, but you can see that in most cases it's a 0. We are also detecting a 14. We're also detecting a 14. Let's see what is 14. This is 0. So 14 is bird. We are detecting birds in this video. Maybe, I don't know what's going on. Maybe we're detecting these birds with a very low confidence, or maybe there are birds I haven't noticed, or maybe it's a misdetection. It doesn't matter. Now let's continue. So these are the detections we are getting. We are unwrapping all these detections, and now it's the time to call our wrapper, right? Now that we have successfully unwrapped absolutely all the detections from Yolov8, from this Yolov8 object detector, now it's the time to call deep sort object tracking in order to start doing our tracking. And I'm going to do something. I'm going to detections.append, and I'm going to create a list which is x1. I'm just going to save all of this, right? This is all the information deep sort needs in order to do the tracking. And now we have the detections. The only thing we need to do, is to call the tracker. Maybe I can do it as an integer, otherwise I may have a problem. Or maybe another way to do it. Maybe another way to do it is do it here. So we just read everything as integers. Let's say x1 equal to int x1, and let's do exactly the same for all the other variables. This is a little noisy, but it's okay. Okay, and let's do the same with class ID. Okay, everything's okay. Okay, perfect. So we have unwrapped all these objects, and we have converted everything into integer, or everything that's an integer, we have made it an integer. And now it's the time to call the wrapper, and in order to do that, I'm going to import the wrapper first, which is from tracker import tracker. And now that we have imported the tracker, the only thing we need to do is to initialize it. I'm going to do it here, tracker equal tracker. I'm going to create a new instance, and then the only thing we need to do is to call, I'm going to do it here, tracker.update, And we need to input, let me show you what we need to input. In order to call update, which is the most important function of the tracker, because it's where it's going to update all the tracking information and everything that's going on in this video, we need to input two parameters, which are the frame and the detections, right? So the detections we have just created, exactly the same object we have created over here, and then we also need to input the frame. Remember, for the way object tracking works, for the way deep sort works, for the way this specific algorithm works, the algorithm computes some features on top of the frame, on top of the objects which were detected, right? It's going to crop the frame and it's going to extract some features from it. So we definitely need to input the frame and then detections. Okay. And now the only thing we need to do is to iterate in all the tracks in this algorithm. So I'm just going to call for track in tracker.tracks, and this is what we are going to do. I'm going to access the track bounding box, right? This will be the bounding box, and then I'm going to access the track ID, which is the most important information from the object tracking algorithm, which is going to be the ID the tracking algorithm has assigned to this object, right? So track ID will be track.trackID. Okay, and that's pretty much all. Remember, we are using an object tracking algorithm, and every time we access one of these objects, each one of these tracks is an object, right? It's one of our objects in the video, and we are accessing the bounding box of that object in this specific frame, and we are accessing the track ID, the object tracking algorithm deep sort has assigned to this object, right? The ID will be exactly the same across all the frames in this video, right? So each object, or actually each person, because I already showed you the video, this video contains people, and all the objects we are going to detect are people, are persons. Well, we already know this, we are detecting birds also for some reason, but it doesn't matter. Most of the objects we are going to detect are people, and each one of these persons is going to have an ID assigned. So the object tracking algorithm deep sort is going to assign a given number, an ID, to each person, and is going to keep the same ID across all the video, right? So absolutely all the frames in that video which contains that person will be with the same ID, right? They will all be labeled with the same ID. So the bounding box is like the specific bounding box of that person or that generic object we are detecting in that specific frame, and then track ID is the ID for that object or that specific person across all the frames in that video. So that's pretty much all for this tracking, and then what we need to do is just plotting a bounding box, a rectangle on top of the frame for each one of these objects. So what I'm going to do is I'm going to define another object, which is another variable, which is called colors, and colors will be something like this. I'm going to import random, and then I'm going to call colors like random.randint. This will be from 0 to 255, and I'm just going to repeat the same 3 times, and this will be for j in range, I don't know, 10. So I'm creating a variable, I'm creating this list colors, which contains 10 completely random colors, and what I'm going to do is I'm going to plot each one of the persons in the video. I'm going to plot each one of these persons with a different color, right? So every time we get a new ID, every time we get a new identifier, we are going to plot this new ID, this new object we are detecting with a new color, right? We are just going to select another color from this list, right? That's the idea of what we will be doing now. So I'm just going to call cp2 rectangle, and now I am going to input the frame, and then the top left corner, which will be x1, y1. I haven't defined what is x1, y1, but it's basically x1, y1, x2, y2. This is bounding box, right? And then I am going to do something like this. This will be x2, y2, which is the bottom right. Then the color, which will be colors. Then the track ID, but divided, or actually mod the length of colors, right? Because remember, this array, this list has only 10 elements, and we will be detecting many objects. So this track ID could have a value which is super huge, and if we don't do something like this, we are just going to get an error, right? So we definitely need to add this mod to make this work, okay? Now that we have specified the color, the only thing we need to do is to specify the width for this rectangle, and that should be all. And let's see if we are doing everything correctly. Let's see if we can just let's see what happens if I press play. Now we should be looking at our frames just like before, but we should be getting a bounding box on top of our frames, and we're not getting it, so we have done something wrong. Let's see what is it. We may need to cast this as an integer. Let's see if that's a problem. Yeah, that was a problem. I needed to cast everything as an integer. And you can see that now we are getting exactly what we should be getting, which is our video. We are getting one frame after the other. We are not getting a real-time detection, obviously. We are executing deep sort, and we are also executing Yolov8, and we are running everything on a CPU. So we are not getting a real-time detection. And we are plotting many different objects. So deep sort it's computing different features and doing different things for each one of the objects you can see in this image. So yeah, we are doing many stuff. We don't have a real-time execution, but nevertheless you can see that everything seems to be working just fine. Everything seems to be working super properly. So the only thing we need to do now is to save this video back to our computer. We have already solved this problem. Everything is ready. Everything is absolutely solved. We have implemented the object detection using Yolov8, and we have done the object tracking using deep sort. So everything is ready. The only thing we need to do now is to save the video back to our local computer, so we have the video with all the different frames and with all the different detections and so on, and we can analyze this video in a much better way if we have the file in our computer. But everything is ready. We should be super happy with ourselves because we have solved the problem already. And what I'm going to do is I'm going to create a new object. I'm going to create it here. Which is cap out, and this will be CV2 video writer, and I need to specify the location of where I'm going to save this video, which maybe I can say something like video out path. I'm just going to save it in my local, in my current directory, and I'm going to save it with the name out.pm4 It's exactly the same. You can choose another name, you can choose another location, but it's exactly the same. And now we need to input a couple of values, and now it will be much better if I can just look at this file. These are the two values we need to input. You can see that this one is related to the codec we are going to use in order to write this file. We are going to write an MP4 file, so we definitely need that value. And then we need to specify the frames per second in this video, right? And we want this output video, we are going to write into our computer, we want to make it the same frames per second as the original video. That's what we want. So we are going to call cap, which is this object, the video we are reading, right? This is the OpenCV object for the video we are reading, and we are going to say cap.get this constant. So we are getting the frames per second of the original video. That's exactly what we are doing here. We are getting the frames per second of the original video. So we are going to make the output video, the video we are going to produce, we are going to make it the exact same frame rate as the original video, which is a very good thing because we want to have like a real experience, right? We want to look at this new video and we want to make it as similar as possible as the original video. And then we need to specify the size, and I'm going to say this will be frame.shape 1 and then frame.shape 0, and I'm going to press enter. Okay, so that's pretty much all, if I'm not mistaken. So I'm just going to take this cap out, I'm going to take this object and I'm going to write the frame here just before I read a new frame. I'm going to write the previous frame, and the previous frame, you can see that it's the one I have just drawn all the rectangles on top. So this is exactly the frame we need to write. And now I am going to release the memory from cap out 2. And that's pretty much all. So if I'm not mistaken, this is pretty much all. I'm going to press play. I am not visualizing the frames anymore. If I go to my local, if I root directory, I don't see any file, anything. So if I press play, everything should work just fine. We should have a huge output with a lot of warnings, a lot of everything. Just ignore all the warnings. They don't really mind in this case. So yeah, we are getting a lot of outputs, but nothing is going on, right? We're not getting any error. And if I go back here, you can see that a new object called out.mp4 has been created, and it's just writing all the frames in my code. So now the only thing we need to do is waiting until this code executes absolutely all the frames, and it just writes absolutely all the frames. So I'm just going to pause the video here and I'm going to fast forward when this is completed. Okay, so the execution is now completed, and let's see our video. Let's see how our video looks like. This is the video we have generated, and you can see that we have different colors for different IDs, for different objects, or for different people we have detected. And you can see that and you can see it's working pretty well. If we look at, for example, this person, you can see that it's a very stable detection. We are detecting absolutely the same person in absolutely all the frames. The color is always the same. If the color is always the same, means it hasn't detected this person as another person, but it's always the same person. And the same happens with absolutely all the people I'm seeing over here. Maybe there are a few misdetections. For example, here I see it goes a little crazy. The detection it's not 100% proper, and there may be some other misdetections maybe over here, and maybe in those cases where we are not getting a good detection. But nevertheless, I would say this is a very good result. So this is going to be all for this video. This is exactly how you can implement an object tracking algorithm using deep sort, using an object detector as Yolov8, right? So, and now that I realize, I see that we are only seeing people, we're only detecting people, and I don't see any bird through the entire video, right? Maybe I am missing the bird. If you notice the bird, please let me know in the comments below, but I don't really see it. But you notice in the detections, we were detecting a few birds. So something that I may recommend you to do is adding something like if score is greater than detection threshold, then and only then save this object, this detector, these detections into this list, right, into the detections list. And I'm going to define detection threshold as, I don't know, maybe 0.5. Let's execute it. Let's see if everything works properly. Everything should work properly because it's only like a very small edit. And this is going to fix some of the misdetections. Maybe this fixes some of the birds we are detecting in this video, and there are not any birds whatsoever. So if you want to do something like this with some value for detection threshold, that's going to make That's going to fix some of the misdetections you may have. So this is going to be all for this video. My name is Felipe, I'm a computer vision engineer, and in this channel I make tutorials, coding tutorials, which are exactly like the one you just watched, exactly like this video. So if these are the videos and if these are the things you're into, I invite you to subscribe to my channel. This is going to be all for today, and see you on the next video.